Hi, kids. Welcome to a very exciting year of physics. We are going to be starting with Unit 1, because Unit 1 is the first unit. So it's usually good to start with the first unit. The one thing I will mention in physics, actually, a couple things I'm going to mention in physics, and then we'll talk a little bit. You guys are going to take some notes, so make sure you have your notebook out. Number one, okay, to really be good at physics and really do well in physics, physics is a class that requires you to understand, not memorize things. Now, for some of you, this is going to be a really tough transition to make because for some of you, you guys have gotten through school and you've been really good at school by just memorizing a bunch of stuff. Well, guess what? If you try to memorize your way through this class, you will struggle. Okay? So the sooner you start approaching this class where, you know what? Rather than just memorize this, so if you start saying things like this, well, is this always true? Stop yourself. You need to ask yourself, why is this true? Rather than memorize, oh, well, this means this. No, understand why that means that. Okay? The sooner you can get that through your head, where you can understand and really approach it where you're really understanding, the sooner you are going to do so much better in this class. So please, please, please understand, don't memorize. In fact, at the end of the school year, we always have the kids fill out a survey. And you want to know what the number one thing that my kids tell me is? That they say, like, we have a question, what would you tell, future kids to be successful in physics? The number one thing that my kids say is, you should understand, not memorize. Okay? And like I said, it's going to be a really tough thing for some of you, but once you start approaching this class the right way, all of a sudden physics, where before you might go, man, physics is hard, all of a sudden you're going to go, man, physics is not that hard. This makes a lot of sense. So anyway, okay, that was 2 minutes of why physics is going to be awesome, and it's also going to be the most important class that you take, because you know what? That honestly, I wish all of you guys were going to be physics majors, but it's probably not going to happen. But you know what? Some of you are going to go on and take physics, which is awesome. But all of you are going to be students for quite a while. And you know what? You will, if you can start approaching all of your classes where rather than trying to memorize a bunch of stuff, where you can actually understand things and make connections, man, your whole education is going to change and things are going to be so much cooler and make more sense. And so anyway, I got goosebumps just talking about it. So anyway, sorry. Unit 1 is kinematics. Now, the kine, that is motion. So we are talking about motion. Matics is the study of. So hence the study of motion. So kinematics, study of motion. That's unit 1. Okay? So to start kinematics today, I'm going to ask you 3 questions. So here is the first question. The first question is, in order for something to stay moving, what has to be applied to it? Okay, so I want you just to pause, and you should probably write out the question, and then pause it, and then write your answer. Okay? Did you pause it and write your answer? All right. I'm guessing everybody said for number 1, the answer is, in order for something to stay moving, you have to apply a force to it. Okay? That's my guesses. If you were like most of my students in my other classes, actually, last year it was all my students, that you're going to say force. Okay, so, all right. So in order for something to stay moving, we have to apply a force. All right, so number 1. Okay, number 2 is going to be this. Okay? If you were to throw a ball on the earth, which is, that's where we are, what would the path look like, and why does it look like that? So you're going to draw the path, and then you are going to explain why. So pause the video, draw the path, and then explain why. Okay? All right, so my guess is you drew something like this. Okay? Because you know what? You've been alive for a while, and you've seen things get thrown horizontally. And why did it get thrown that way or go that way? Is because, you know what? Oh yeah, gravity is acting on it. And I hope this is not a big stretch for anybody, but does everybody agree that gravity is a force? Okay. All right. So, number one, number two. Okay. Here's our question number three, and you're gonna pause it and then answer it. So, if you were in deep outer space, so when I say deep outer space, I'm essentially saying we're so far away from everything else that we don't have to worry about gravity. So we're gonna pretend that like we don't have gravity anymore. We don't have to worry about gravity because we're so far away from every other thing that you don't have to worry about gravity. Okay, you throw a ball horizontally. What does the path of the ball look like? Why does it look that? So you're gonna pause it. You're gonna pause it, and then you're going to explain it. So, all right, so did everybody pause it? Okay, so my hope is for number three, you guys said, oh, well, my path is just gonna look like this. Okay, that's supposed to be a horizontal line. That's, not a great horizontal line, but, whatever. And you would say, well, the reason why it looks horizontal, well, up here we threw it horizontal and got pulled down because there's a force acting on gravity. Well, the reason that if I get rid of this force, so there is no force acting on it, well, then it's just going to keep moving in a straight line. Oh, wait a second here. Wait, let's go back to number one again. In order for something to stay moving, what has to be applied to it? You guys all said force. But wait a second, down here you told me this. In fact, you're right. The real answer to number one is nothing. Okay? I know. I'm going to say some words, and I would like you to finish this statement, and then I'll write it down. Okay? So you ready? An object at rest. Did you finish it? Yep, that's right. Stays at rest. An object in motion. Yeah, that's right. Finish it. Yep, stays in motion. Okay, and there's more to that, and we'll write it all down. It's really an object at rest stays at rest, an object in motion stays in motion along a straight line, unless acted on by a net outside force, which I'll write down in a minute. But okay, my guess is you have heard those words before. An object in motion stays in motion. My guess is I'm going to dare say that you have actually perhaps maybe memorized those words. But if you said force for number one, and don't worry if you did, because everybody does, that just goes back to this idea that, to be successful at physics, you can't memorize. You have to understand. So it's more than just saying the words an object in motion stays in motion. You have to deep down understand it to make sure that you follow what it means, okay? And that is called Newton's first law. So let's actually write it down. Newton's first law, okay? Which sometimes I'm just going to write it like this. NFL for, Newton's first law. An object at rest stays at rest. An object in motion stays in motion. These are some important words here. Along a straight line, unless acted on by a net outside force. Okay. All right, so let's talk a little bit about this. Okay, this is Newton's first law. It's also called the law of inertia, but more on inertia later. So an object at rest stays at rest. Well, duh, that's you guys ready for a really exciting, demo? Ready? Hey, look, there's a calculator. It's at rest, See, it's staying at rest. Isn't that amazing? I know. It's such a good demo. But an object in motion stays in motion along a straight line unless acted on by a net outside force. So let's talk about what this means by a net outside force. Okay? So here's what I mean by a net outside force. So let's go back to my amazing demo of the calculator just sitting there on the table here. So here's the tabletop. Here's the calculator sitting on it. I know. That looks just like the calculator. Look, there's the little buttons, Oh yeah, that looks just like it. The one thing you're going to learn about me is I'm minored in art. And I know that's my pictures are just going to be amazing. That's obviously a calculator. But if we were to draw the forces acting on this calculator, okay, here's what this is really saying. It's not saying that for an object to stay at rest, that no force acts on it. It's just that if you add all the forces up, then you get zero. That's the net force. So what forces are acting on the calculator? Well, there's the force of gravity going down, and then there's the force of the table going up. But these two forces are the same size. They're going to cancel out. So there is no net force. The net force is zero. Hence, an object at rest stays at rest. Okay? But that's, so that hopefully makes sense. Whereas the same thing for this ball, for example, if we had this ball, okay, and we were to draw the forces acting on that ball, well, that ball is moving this way, but there's a force of gravity acting on it down. Hence, you know what? Its motion is going to change because of that gravity. Where this thing, well, I have this ball here. After it's left your hand, what's acting on it? Well, nothing's acting on it. An object in motion stays in motion. Okay? More on that when we're talking about things with friction in a little bit. But that's a great start for us. Hope that makes sense. Bye, kids!